In today's video, Academic Daddy is going to be teaching you everything about dimensions, or you say units and dimension. Units and dimension. For those of us that did technical drawing in school, you know that anytime you hear dimension, what comes to your mind is measurement. That's what comes to your mind. Those of us that did technical drawing, dimension, they tell you put the dimension, put the dimension. So dimension in physics is being rated with what we call the S1 units. So that's what we make use of. And S1 units simply means system international units. So this unit was agreed in the year 1960. That's when this unit was agreed. So they had a conference of weights and measures. So it was recommended that the metric system called System International Units be used. So it is used on the fact that three major measurements, three major fundamental quantities be used, and which is that length, that meter should be used as the unit for length. Seconds should be used as the unit for time, and that kilogram should be used as the unit for mass. So you know that this means kg, s, and m. So these are the units. These are the quantities. So that was it. So units, quantities. So that was the agreement. So there are seven fundamental quantities and so many quantities called derived quantities. But you need to just know this introductory part. So the international system of units are used universally, and they contain two major classes of units. They contain two major units class. Number one is what we call fundamental units. Number two is what we call derived units. So fundamental units are units used to describe fundamental quantities, and fundamental quantities are independent quantities. They occur by nature. They don't depend on anybody. They don't depend on any other quantity. While derived quantities are dependent on the fundamental quantities. So that means that every unit of this is coiled from putting the fundamental quantities together. For example, when I have L and T, that is length and time. Then if I come here and I have something like LT minus 1, that is L over T. This is the same thing in this. So this is for velocity. So velocity is a derived quantity. So calling it. Now if you know this, now that you know this, you also need to know that there's something called the 7 fundamental quantities. And you need to know that these 7 fundamental quantities are mass. Mass is a quantity. We say that mass is the amount of matter contained in an object, the amount of matter available to a substance. So mass, we have time, we have length, we have amount in mole, we have temperature, we have current, electric current, we have luminous intensity. So 1, 2, 3, 4, 5, 6, 7. So that's the fundamental. These are fundamental quantities. These are fundamental quantities. Now the units. You need to know about the units. So the unit of mass is kg, kilogram. Time is seconds. Length is meter. Amount in mole is mole. Just mole. MOL. Temperature is degree Kelvin. Current is ampere. Luminous intensity is candela, represented as CD. That's A. So once you know this, once you've come to know this, you're good to go. So the next part, you need to know, okay, before I proceed, you need to know that these are the 7 fundamental quantities, and all these 7 fundamental quantities are grouped into what we call the scalar quantities. Scalar quantities in the sense that they have magnitude but no direction. So as we have physical quantities and we have its between fundamental and derived, we now have that these fundamental quantities are all scalars. They have magnitude, which is why you cannot tell somebody, I have a pot of food in northeast direction. You can never say that. Even if you say it, you are not feeling fine for saying that. So we move to the next one, which is the derived units. So you need to know that derived units are units that are dependent on the fundamental units. So they are those units obtained by the combination of fundamental units. So there are units obtained by the combination of fundamental units. Example is the unit of force. We know that force is a quantity. So we can say that force is a derived quantity since the unit of force is made up of fundamental quantities that came together, or you say that was brought together. So force, the unit is Newton. And you know that according to second law of Newton, force is directly proportional to change, or the rate of change of momentum, which gives us that F is equals to ME. Understand? And gives us that this is F equals to mv minus u all over t. And you know that everything here is acceleration. So it's the same thing with this. So this is what that law is talking about. So if I know this, m is a fundamental quantity, mass. Acceleration is made up of v, and velocity is displacement over time. So this is the same thing as lt minus 2. Remember that velocity is equals to s over t. And s over t means distance. Distance means length. T means seconds as units. Seconds as units. But notice that whenever we are doing the units, whenever we are trying to get these units, so if this is if this is s for t and this is length for displacement, so that means that this is the same thing as, let me write m here for the units, ms. So then they said that is for velocity. That means, and here we are having mass over t. So this is the same thing as meter over s divided by another t. And this is the same thing as m over s divided by s. So if this is m over s divided by s, this is the same thing as m over s times 1 over s, which is the same thing as m over s square. Now in this it said that when something is having a positive value up, that if it's coming up to the numerator, it will change to minus. So this is ms raised to power minus 2. So this is the unit of force. This is the unit of force, meter per second square. Meter per second square. Now, this thing that I'm having here, mlt minus 2, this is what we call dimension. Dimension is done using those three major fundamental quantities. There are 7 of them, but the 3 major ones are mass, length, and time. So if you know that the unit of this is meter per second square, so where you see meter, replace it with L. Where you see second, replace it with T. Now, wherever you see mass, instead of using kg, you replace it with kilogram. So this is the unit of acceleration, sorry. Then force is kg. So it will be kilogram meter per second square for force. Kilogram meter per second square. So where you see kg, replace it with m. Then put this. So that is why we have this. So this is the units. This is the dimension. You do dimension using mass, length, time, while the units is simply those fundamental units, which includes kilogram, meter, seconds. So now that you know this, let's take another example. Okay, now that you know this, let's take another example of a derived quantity. All right, so for density, we know that density can mean a whole lot of things, but in standard, it's the same thing as mass over volume. This thing means that when mass is increasing, density is increasing. When volume is decreasing, density is increasing. So mass over volume. Now remember that the unit of mass is kg. The unit of volume is liter raised to power 3. So and that liter that we know talks about length, or you say distance. So this is the same thing as m raised to power 3, and this is the same thing as, so this is the units. Now kg is mass, m3 is length. So this is the same thing as saying that the dimension of density is the same thing as m L. Since this is 3 raised to power 3 and is positive, if it's coming up to the numerator, it will change to minus. So it's ml raised to power minus 3. So it's ml raised to power minus 3. So ml raised to power minus 3. And since we know that this is a dimension now, this is the dimension. It simply means that this one can as well be written relating as kgm minus 3, the units for density. So let's take another example of a derived unit. So this question says, derive the expression for the period of a simple pendulum t. We know that simple pendulum has different formula. It has a formula which is t equals to 1 over f. It also has formula of 2 pi roots m over k, or you say x, that is k for the extension. So if they are telling us to get this now, the period, they are giving us this. To find it, it simply means that I'll have a situation whereby t will be equals to k is a dimensionless constant which is equals to 1, then m raised to power x, then l. G is acceleration due to gravity, which is the same thing as lt raised to power minus 2. So all this enclosed by z. So this is the same thing as saying mx, l here, this will be l, then l raised to power z, t raised to power minus 2z. So this is the same thing as saying mx, then l is having this, and there's an invisible one here, so this is the same thing as 1 plus z for it. 1 plus z, but notice that this is carrying y and this is carrying y. So instead of 1, it's going to be just the y plus z. So this is t minus 2 z. Then I have t this side. Now let's ask ourselves, I have t. Do I have m on the left hand side? No. So it's the same thing as raised to power 0, because anything raised to power 0 is still the same thing as times invisible 1. Then all raised to power x. So we can say that on this side, m0 is equals to mx, which means that x is equals to 0 here. The value of x here is equals to 0. Then this side I have t l raised to power 0, because l is not found on this left hand side. So if it's not found on the left hand side, it's now the same thing as raised to power y plus z. So you can see that this is the same thing as n raised to power 0, n raised to power 1 plus z. You can see that this is the same thing as 0 equals to y plus z, which means that making y subject of the formula, this can move over to this side to become minus y equals to z. Making y subject formula, y now becomes y positive equals to minus z. Now for t is on this side, t is on this side, so this is t raised to power 1. In t raised to power 1 is that, and then t raised to power minus 2z. Making this, I now have that this is the same thing as 1 equals to minus 2z. Divide both sides by the coefficient of z, which is minus 2. This will cancel, so that z is equals to minus 1 over 2. So let's substitute the value. So this is the same thing as y equals to minus 1 over 2. This will cancel. So that y is the same thing as 1 over 2. Then x. So that means the total value is simply x equals to 0, y equals to 1 over 2, and z equals to minus half. So that this now becomes the same thing as saying t equals to km0 l 1 over 2, then g minus 1 over 2. And this is the same thing as saying k is 1, dimensionless constant, times 1. N t raised to power 0 is 1. So this is the same thing as saying t raised to power root l times 1 over root g. Anything raised to power minus half is the same thing as 1 all over that. So this is the same thing as t equals to root l all over root g equals to l over g. Now remember that k is our invisible constant. So this is the same thing as t equals to l over g. So if we bring our k constant, so this is the same thing as k means 2 pi. K was found to mean 2 pi. So this is the same thing as 2 pi root l over g. So this is it. This is a very common question. So thank you very much for today. This is our first class on dimension. So if you go through this on our textbook, you see applications of dimension. So we'll be using this to teach you in class. But do well to study the textbook as it was shared in class today. So thank you very much.